Hello everybody, my name is Rahul, my teammates are Robert, Derek, and Sepper, and we are Team 1, the G-Bots. The House of Quality shows the most important customer requirements as high scoring and autonomous, both with importance ratings of 10. Other important requirements are ease of setup and easy to repair with importance ratings of 8 and 9 respectively. These will be important later in the evaluation matrix. Now let's move on to the final design as well as design alternatives. Design Alternative 1, nicknamed Demolition Derby, features a ramp and cart to move the dog bone and a drawer arm and motor to move the tennis balls. An IR sensor identifies the red zone as a dispenser releases the ping pong balls. Design Alternative 2, nicknamed Wacky Inflatable Guy, features a pneumatic arm and wedge to move to and get the tennis balls. A hinge arm gets to the center while a switch release identifies a barrier drop. Design Alternative 3, nicknamed the Flying J, features a hinge constraint to stay out of the EMP zone, a switch that identifies the red zone, and a pneumatic arm with a motor pulling it back to get the tennis balls, while a scissor arm and an IR sensor move to the doll and identify the barrier drop. Design Alternative 4, nicknamed Ping Pong Sensei, features a drawer arm and an actuator to get to the tennis balls, a hinged arm and flat arm to move the dog bone, and a rotating arm to get to the center with a scoop to tame the doll.
After looking at the evaluation matrix, a final design is chosen. This design scored the highest because of its efficiency with each task. To get to the dog bone, this device uses a hinged arm with a wheel attached to it. After reaching the dog bone, it uses a flat ram attached to the end of the hinged arm to push the dog bone out of the home zone. To retrieve the tennis balls, this device has 2 hinged arms and 2 actuators that are attached to each other with strings. On activation, the actuators push the hinged arms over the tennis balls and then pull the hinged arms back in, thus bringing the tennis balls into the home zone. To get to the center, this device uses a drawer arm with a base attached to it. After reaching the center, there is a PVC pipe attached to the center base, with the ping pong balls inside it. Attached to the PVC pipe is a solenoid door that's input is the roller switch telling us when the red zone is in front of us. Once the red zone is in front of us, the solenoid door will open, releasing the ping pong balls. On this center base is also attached a hinged arm with a ring attached to it. This hinged arm is held in place by a solenoid with a loaded mousetrap underneath it. The input for the solenoid is the IR sensor telling us when the shield is dropped on Morpheus. After the shield is dropped, the solenoid releases and the hinged arm goes over Morpheus. To regress, this device uses a motor pulley with strings attached to the drawer arm and the hinged arm for the bone and pulls everything back in, thus pulling in Morpheus and leaving the dog bone out of the home zone.
I'm going to be going into the evaluation matrix and how we utilize this to determine our final design and how it compared to the other design alternatives that we came up with. As you can see on this slide, in the red box we have our final design, and it has the highest relative total compared to the other 4 designs. On this slide you can see we have highlighted some of the key criteria that we need to focus on or that made the final design different. As you can see, for high scoring, the final design received a score of 4 compared to the others who did not receive anything higher than a 3. As far as ease of setup, the final design received a 3, while the others only received a 2. This means that the final design differentiated itself in 2 of the highest priority and highest importance criteria that we have. One thing to point out is the ease of repair, as you can see on the screen. Since everything has a 2 or a 1, this is something we need to focus on as a team to make better so that in the competition we can repair our robot easily. As far as conclusions and next steps, the final design has the potential to score us the highest number of points. It also meets the most customer requirements set in the House of Quality. Our evaluation matrix was utilized to determine the final design and focus mainly on high scoring, cost, and ease of setup. As far as next steps for the team, we want to continue to test and refine subsystems of the robot so that we can make them better and more efficient. We want to make sure boxing and reset times stay within engineering requirements and remain consistent throughout the entire process. And finally, we want to prepare replacement parts to increase ease of repair and make life easy when it comes to competition and replacing parts on our robot. Thank you for your time, and we will take questions at this time.